Hello guys, this is Vikram and welcome to my channel. In this video, we'll see how to write a microservice in Python, and that too using Flask as the web development framework. So we are going to start from very scratch, right from installing Python in our Windows system and writing the Python script. And then we'll move on to writing the Docker file for this Python based application. We'll also see how to build this Docker image and then run it using Docker Compose. And then we'll create various Kubernetes Manifest files like deployment and service object for this application, followed by creating the Helm chart. So we have already seen this kind of application in our Kubernetes and Docker demos, but this time we'll be doing everything from scratch, right from installing Python in our Windows system. So these are the various parts of the complete demo. We'll start off with installing Python in our PC, and then we'll see what are Python virtual environments and why these are needed. And then once these are installed, we'll be installing various extensions for Python in VS Code, and then we'll start writing the Python based application or Python web application using Flask. We are going to follow the official documentation by taking the few examples. We are not going to make a huge web application, so we'll just create few endpoints and see how to Dockerize, and also we'll see how to run them locally, and then we'll see how to write dynamic web pages using Jinja templating. So we'll be creating index.html files and see how to give dynamic information to those files. And we'll also see how to freeze your Python dependencies using pip. And then once everything is running properly in our local, we are going to write the Dockerfile for this application and then build it. We are also going to see how to write the Docker Compose file from scratch and then deploy it into the Docker. And finally, we'll move on to writing the Kubernetes Manifest files like the deployment and service object. And then we'll see how to create Helm chart out of these particular manifest files. So the prerequisites are, we need Python 3.10 along with pip install. We would also need Docker and Docker Compose install because we would be building the images and running them as a Docker container first before moving into Kubernetes. At the same time, we also need Kubernetes clusters like Minikube cluster and utilities like kubectl and Helm CLI. And for writing the source code, I prefer VS Code, but you can also use Notepad or Notepad++. So what are web frameworks? A web framework is a code library, so that makes it easier for us to develop web applications by providing common patterns for building reliable, scalable and maintainable web applications. So these are nothing but a code libraries that makes or that provides various patterns which we can reuse to build highly scalable web applications. In Python, some of the popular frameworks include Django, Flask and FastAPI. So for this demo, we'll be using Flask, but in the coming videos, I'm planning to use FastAPI as well. A framework will provide various functionalities in the source code or through extensions that it makes it easy to perform various common operations required to run web applications. The common operations like the URL routing depending upon various URL parameters, and then input form validation and handling, and XML, HTML and JSON output format with the templating engine. We can also have database connections with object relational mapper, which we call it as ORMs. We can also have web security and session controls, everything baked into web frameworks. So we will be seeing quite a few of these operations in Flask based framework. So now let us start with installing various tools that are required to build the web application. So first I'm going to open my terminal and then see if Python is installed or not by running python hyphen version. So in my case, Python is not installed. So what I'll be doing as the first step is, before installing Python, I would be creating a GitHub repository and then we'll clone it and then start from there. So I'm in my GitHub page. I'm going to create a new repository called Microservices in Python. So I am going to initialize it with a readme file and then create a repository. So first I'll be cloning this repository so that we'll take it from here. So I'm going to go to the downloads directory and then use git clone to clone this particular repository. And then I'll cd into this directory and then use this particular folder, and I'll open this folder in the VS Code. So the prerequisite is you need to have the VS Code installed. So doing code space dot will open my particular application inside the VS Code. So first thing which I'll do is first I'll create a file known as a readme. Okay, so we already have this readme.md file, so we'll start modifying this. So first I'm going to write each and every step that I'm going to create as a part of this example. So first thing is we'll be installing Python. So already we have mentioned or listed out every step here. So I'm going to copy everything from this presentation and I'll copy it here. So the first thing is which we are going to see is installing Python 3.10, which is the latest version, and then we'll start to understand what are Python virtual environments and why these are needed, and then we'll create we'll install various Python plugins in the VS Code, followed by creating a sample Flask based application. And then once this is done and running inside our local machine, we are going to see how to generate dynamic web pages using Jinja templating engine. And then once everything is running, we are going to use pip to freeze the Python dependencies. So we'll see what all Python dependencies are needed for this web application. And then once everything is available, we are going to start the Dockerfile for this complete application, followed by writing the Docker compose file. So in every step, we are going to test it locally by running the Docker container either through Docker run command or through the Docker compose command. And at the end, we are going to see how to write the manifest files for the deployment object and the service object, followed by creating the complete Helm chart itself. So let us start with the first step, which is downloading and installing Python. So I'll head over to official documentation of Python. So it is Python download if you search it. So the first link will be the official link. So all you have to do is to click on this button to download Python. So in my case, I've already downloaded it. So it is in my downloads folder. So what I'll do is I'll double click on the exe file, and then I'll also check this add Python 3.10 to path and click on customize installation. So I'll select all of these, click on next, and I'll also check this install for all users and then click on install. So this is going to take some time. So Python installation is successful. I'm going to close this dialog box. So I'll open a terminal. So Python won't be detected in the current terminal. So I'm going to close this and I'll reopen the new terminal. And then you can type Python -- version to see the latest version of Python install. So it is Python 3.10. You can also see what is the pip version. So pip is a package manager for all the Python based modules. So pip version is 21.2.3. So these are the different versions of Python and pip. So I'm going to close this dialog box, and now the second step is to understand what is Python virtual environment. So with the Python, so when you install Python for the first time, Python is going to install in the C drive programs files under Python 3.10 folder, which is Python 3.10 folder. So this is where Python is going to store all the libraries that we are going to download through pip. But imagine we have two different applications that require two different sort of dependencies. Let's say one application needs YAML 1.0 as the dependency, another application needs YAML 1.1 as the dependency. But the problem is we cannot have two different versions of a library in the same system. So if you are working on two different projects, so you should make sure that both the projects either satisfy a common library, or you have to go back and forth by uninstalling a particular library and then installing a new version, so depending upon the requirement. So in order to avoid this, so what we are going to do is we are going to create virtual environments for each and every application. So these virtual environments are our containers. So as containers are isolated from each other, these virtual environments are also isolated from each other. So in order to learn more about the Python virtual environments and how to create one, so you can type Python virtual environment. So this is going to take us to the official documentation of the virtual environments. So in the introduction part, they've explained it very clearly. Python applications will often use packages and modules that don't come as a part of standard library. So with your Python installation, you will get only a few packages that are coming as a standard one, but some application needs specific version of a library because the application may require that a particular bug has been fixed, or the application may be returned using an obsolete version. So this is some sort of introduction. So in the next paragraph they have explained it that if a particular application A needs version 1.0 and if there is another application B that needs 2.0, then the requirements are in conflict. That means that either you install 1.0 and work with application A, or you install 2.0 and work with application B, but at the same time you cannot have 1.0 and 2.0 as the library dependencies. So this is where our virtual environments comes into the picture. So virtual environment is nothing but a self-contained directory. So it will create a directory, and inside that you can put your own dependencies. So we can create an n number of virtual environments, and these environments are completely isolated from each other. So for every application we create a virtual environment and we put all the dependencies in that virtual environment. Since no two virtual environments will collide with each other, so we can have different versions of applications and their dependencies running inside the same machine. So in order to create a virtual environment, and which I highly suggest that we should do, so we should use this Python -m module. -m stands for the module over here, and the module name is venv, and this is the folder that is going to be created, that is the virtual environment folder. So I'll take this command over here and then I'll go to the VS Code. The first step that I'm going to do is so creating this virtual environment. I'm going to open the terminal. So here we are inside the microservices in Python folder. I'm just going to paste this, but the problem is we don't have Python 3 binary, it is only Python. So I can just use Python -m virtualenv tutorial env. So this is going to create a particular directory. So if you try to open this directory, you can see that we have include library scripts. So this is exactly like your Python installation. That means for every virtual environment that you create, you're automatically creating a separate Python installation instance for this particular application. That means you can have n number of these virtual environments, and these environments are completely isolated from each other. So now I have the virtual environment, so I need to activate it. So for activating, we have the activate.bat and deactivate.bat inside the scripts folder. So I'll go to the official documentation and I'll see how to activate this. So all you have to do is inside this folder that we have just created, so we have the scripts directory, and inside that we have activate.bat file. So I'll just copy this command over from there and I'll paste it here. So this is going to activate my virtual environment. So how do I identify whether virtual environment is activated or not? So it is through this prompt over here. So earlier we didn't have this prompt, now we have this prompt. That means that we are inside the virtual environment. So inside this virtual environment also we have Python. So if you just type Python -- version, so you can also see that it is basically the same version so that we have installed in the machine. So basically it is just like cloning the existing installation and putting it in an isolated environment. So this is the advantage. Now I can work with this particular application inside this virtual environment by creating or installing any sort of dependencies, and these dependencies are completely isolated from your main Python installation. So for now we have just activated the Python virtual environment, and this is for the Windows. For Unix or Mac OS, so you can use this source command. So that's it. So we have just activated the virtual environment, and then you can also install any sort of dependency using pip install and the dependency name along with the dependency version. So we will see about all these installations in the coming video. So in this video, so we are going to see all these in this video. So I can also do pip list, so to see all the dependencies inside this virtual environment. So if you see, we only get the default ones. So it is taking some time. So we only have these default ones, which are pip and setup tools. So now let us go to the next step, which is installing Python VS Code extension. So VS Code will also have various Python plugins. So if we activate them, so they will give a lot of other features like auto completion and etc. So I'll go to this extension tab over here, and then I'll select Python. So I'll search for Python and then click on this first, which is from Microsoft itself, and then click on install. So Python extension is enabled. I'm going to close that window. So the next thing is we need to set up the Python interpreter, which we'll see in some time. Now what we'll do is we'll go to the next step, which is creating the sample Flask application. So we are going to see it from the official documentation itself. So I'm just going to type Python Flask Python. So this will take me to the official Flask documentation. So this is the official Flask documentation. So you can click on this user guide directly. So this will take you to the user guide. If you want to learn more about the Flask, so which is nothing but a framework for developing the web applications, and you can also click on the Python version that is needed. So basically Flask supports anything more than Python 3.6, and also we need Flask as the dependency to work with Python Flask. And we also need virtual environments, which we have just created. So it is not needed if you are working on only single project, but if you have multiple project that requires multiple dependencies, so it is always suggested to go for the virtual environments. And then how to install Flask? So it is through pip install Flask. So I'm going to take this command and then going to run it inside the VS Code. If you see here, we already activated the virtual environment. So I'm just going to paste this command, which is pip install Flask with F as the capital letter. So this is going to install Flask, and along with the other dependencies like markups, safe, Jinja 2, etc. So now if you want to see what all dependencies installed, you can just do pip list. So this is going to show me everything. So as you see, along with the Flask, we also have other dependencies automatically downloaded, which are Jinja 2, markup, safe, so rest of the other things. So if you are not sure what is the use of this virtual environment now, so what I'll do is I'll open the terminal and do the same command, which is pip list. So now we are using the systems Python interpreter or the installation. So if you see, so we don't have Flask here. The reason is we have created a virtual environment, and inside that virtual environment we are using pip to install the Flask dependency. So for now we are using only we have installed these dependencies only in the virtual environment. So similarly, I can create a lot of virtual environments, and I can install various dependencies inside that virtual environment. So now virtual environment creation is also done, and installing Flask is also done. So now let us first write a small Python application and see whether Python is working or not. So I'm going to create a new folder over here. And one more thing is, before creating this new folder, so I wanted to create .gitignore, because I don't want to push any of these tutorial env folder, which is nothing but the virtual environment, to GitHub. So I'm going to just write the folder name tutorial env. So this will be excluded when I'm trying to push my changes into GitHub. So this is the first entry in the gitignore. And now what I'll do is I'll create a new folder called src, and inside this src I'm going to create a file known as app.py. So app.py. So now I'm going to test the Python installation by just typing a simple print statement, which is hello Python, and I'm going to save this. And now in order to run it, you can click on this button over here and click on run Python file. So if you see here, So your Python is being run inside the virtual environment. If you see, the interpreter that is being invoked is not your system interpreter, which is inside your C drive program files. The interpreter is from the virtual environment that we have just created. So that means that the python.exe file is from the scripts directory of the tutorial env. So this is where your this is the python.exe that your system is currently using. So now we are executing, we have executed the first Python program. So now we'll go to the official documentation of Flask and see how to create a simple web application or a RESTful API. So we have installed. Now we are going to go to the main page, and then we'll see a minimal application. So this is the minimal application of Flask, and you can see we are first importing the Flask class using from Flask import Flask, and then we are instantiating an object, and then we are creating various routes. So what I'll do is I'm going to just copy this complete source code and then paste it in the, I'll replace the print statement and I'll paste it here. So from Flask we are importing the Flask class, and then we are instantiating an object known as app, and then this is our first route. So the routes are, these are the HTTP routes. So whenever you access Flask based application on slash, so it is going to invoke this. So it is going to invoke this hello world as the function, and then it is going to return this HTML object, so which is nothing but hello world. So it is also mentioned clearly in the documentation also. So first we import the Flask class and then instantiate this class with an object, and then we create a route. So the route is nothing but a particular decorator, so that will dynamically change the function over here. So we'll then use route decorator to tell Flask what URL should trigger this function. So in my case, so the URL slash will trigger this particular hello world function. So in order to run this, so there are multiple ways. So first thing is, if you are working on Windows, you should select the CMD, and what we are doing is we are selecting the Flask app as hello, because here the file name that they have used is hello.py. so that's the reason why they are using hello. So they have saved it as hello.py, so that's why they are setting this Flask app environment variable as hello, and then simply doing Flask run. Flask will automatically take this environment variable and run this Python file. So this is not needed for every use case. So what we can do is we can simply run it using Python. So I should go into the src directory. So cd into the src directory. So here we have, sorry, ls won't work. So here we have app.py. So I'm going to run it using Python app.py. So it is going to give me hello world. Sorry, I have not saved this file, so that's why it was giving me earlier print statement. Now we can run using Python app.py, but before doing that, so let us see where, on which port the Python Flask generally runs. So by default Python Flask runs on 5000 as the port. So you can also change it to some other port. So if you want to know how to do it, so we can just search for Flask running on different port. So you can take any link. So this is how you to run the Flask on a different port. So I'm going to take this command and then going to paste it here. So this is an if condition, so that sees whether you are running this file as it is or you are importing it. So if name is equal to main, that means that if you are running this Python file directly, then only app run will work. So this app run, it is now running on the same local host and it is using 80 as the port. So default it is 5000. So you can also change it to some other port. So right now I'm using it as 5000 itself. So now in order to run this Python file, all you have to do is Python app.py. So this is going to start my server, and this is the URL. So the URL is, so the IP address of my machine colon 5000, it is the port on which Python Flask application is listening on. So we have the first endpoint, so that is slash, so which is just displaying hello world. So if you see the type of the response, so all you have to do is just right click on this page and then select the network, and you have to refresh this page. So this is the response. So if you click on this response or the headers information, you can see that the response is of type text slash HTML. But generally all the web applications give JSON as the output, so that it can so that other microservices can read that JSON output. So it is difficult to parse this HTML output. So what we'll do in the coming video, so we are going to change this response type to the JSON, because the response type is now text slash HTML. So I'm going to go back to the VS Code. Now let us try to create one more endpoint called slash health. So this slash health is pretty much needed for all the microservices, because so using slash health we can only detect, or using slash health we can detect whether the application is up and running successfully. So in the readiness and liveness probes of the Kubernetes, so we can use this endpoint to see whether your particular container is alive or dead. So what I'm going to do is I'm going to create one more route here. So the route is for the slash health. So for slash health also I'm going to create one more function. I'm going to create a function known as health, and then here what I'm going to do is I'm going to return a JSON response. So there are many ways you can convert a string into a JSON, but in case of Python we have some class known as JSONify. So using JSONify we can convert any object into a JSON object. So all I have to do is I have to call JSONify, and then for its function I can pass a key value pair in the form of key equal to value. So in this case what I'm doing, I'm going to use status as the key, and then value in terms of string it is up. So now this particular health endpoint, if someone reaches this particular application on slash health, it is going to respond with the status is equal to up, and that too as a JSON object. So since I made the changes, so I'm going to save this file and I'll reload the server by clicking on Ctrl+C to stop the server, and again I'll do python app.py. It is going to restart my server. So it is the same IP address. So if you do refresh, since we are hitting the slash as the endpoint, we are going to get the hello world. But if you do slash health as the endpoint, so it is going to send me a JSON response. See, if you see from the source code, it is status is equal to up, but in the browser it is status colon up. So this is a JSON value. So if you're not sure, just right click and select inspect, go to the network tab, and then refresh this particular page. Now click on this health endpoint over here. Now if you see the response address, the content is application/JSON. You can also see the response, which is the same, status is equal to up. So this is how you return JSON responses using the JSONify. So which is a particular we are importing this function from the Flask. So now health endpoint is created. So let us now try to create static web pages. So what I'll do is I'll go to the official documentation. Since we are done with running the basic web server or basic we have created the basic API endpoints. So by default the Flask application runs on 5000. You can also change it to 80 over here. So the web server listens on port 80. So now let us go to the rest of the documentation to see if we can do some more things. So this is how we do the routing. So here we have the routing for /hello, and here they are just returning a string as the response. So in the next demo, in the coming demo, we'll see how to serve the static files. And the Flask will support various HTTP methods. So by default, if you're not mentioning any methods, it is going to be get. But if you have any methods like post, put, delete, you can also use them by mentioning the method in the array like this. So here this particular route will trigger for both get and post API calls. But in order to do the differentiation between get and post, so here we have created an if else statement. If the request.method is equal to post, then it is going to return this particular information, but if it is a get, it is going to return this particular information. So here this is a function call, and here this is one more function call. So let us see now how to serve the static files or the HTML files. Basically, Flask uses Jinja 2 as the templating engine, so we can have dynamic web pages created using Jinja 2 templating. So all you have to do is you have to create a folder structure, like inside the source directory we have to create one more folder known as templates, and inside this template you can put your HTML file. So what we'll see now is we are going to create a static index.html page, so inside this templates folder, and then we'll see how to modify it or templatize with Jinja 2 templating. So I'll go to the VS Code, and then inside the src folder I'm going to create one more folder. I'm going to name this folder as templates. So inside these templates I'm going to create one more file known as index.html. So I'm going to write some HTML code. So basically I'll start from HTML tag, and then we will close it. So and inside the head section, so I'm going to give the title. So the title is I'm just writing Dockerizing Python web application. So I'm going to close this title tag, and also I'm going to close this head tag. And now inside the body I'm going to write some static code. So the static code is I'm going to use the h1 as the heading tag, and then I'll just write simple web application using Python Flask framework. So this is the first header value. So let's see how to dynamically change this. Since we now have the HTML static file, so how to render this? So there are various ways we can render this. So in the documentation it is said that so we have to import this particular function called render template. So we have to include this as well, render template. And then for rendering, what I'll do is I'm going to create one more endpoint known as app.route. So the route I'm just going to say it as details, so /details, and then I'm going to define a function so called details function, and here I have to exactly copy this return render template statement. So I'm going to copy this, go to the VS Code, and then paste it. So here I am rendering the particular template, so it will automatically detect the file from the templates directory. But so in my case, the inside the template directory, the index file is the HTML file is index.html. I'm going to change its name and remove the rest of the statements from inside. So I'm just saving this file, and then I'll stop this server and then restart it. So this time what I'll do is I'll go to an endpoint known as details. So this is going to serve me a static HTML page, which is simple web application using Python Flask framework. But so far we have been serving the static page. So what if I wanted to serve the dynamic content? So I can also modify this index.html with certain placeholders. So these placeholders will get the values from the main app.py file at the rendering state. So what I'll do is for rendering, so I just wanted to show the host name and IP address of the particular app, the machine which is running this Python application. So I have to write a logic to fetch all the details of the host name and IP of this particular machine where my application will be running. So inside the Docker or Kubernetes, it is going to be the container host name and the container IP address. So what I'm going to do is I'm going to create a one more function call, the function called the fetch details. So naming is up to you, and then I'm going to return two values from this particular function call, so which is nothing but your host name, and then I'm going to return the IP address of the particular instance. But here I don't have them, so what we have to do is we have to have a logic for fetching the host name and IP address of this particular container. So what I'll do is, so I'm going to go to web and I'll search for it. So hostname and IP using Flask. So there will be plenty of website that are going to give you that information. So we are going to select one such website. So we can use Stack Overflow or any other website. So this is the IP address of visitors, so it is not this one. Fetch hostname and IP using, it's not Flask, basically it is in Python, because so there is nothing like it is different from, yeah. So we are going to take this logic host name, and before that we need to import this particular library called socket. So I'm going to import this using import keyword, import socket, and then I'm going to fetch the host name and IP by using these two commands. I'm going to paste them, so I'll explain in a while. So here how we are doing is we are fetching the host name by calling the socket, and then we are calling one more function inside it called get host name. So this is going to give me the host name, and the host IP, it is through the same command, but instead of get host name, it is get host by name. So that means it is going to get the IP address. So as an input I have to pass the host name. So here host name and IP address are available now, so it is up to us to print them in the console or not. So I'm going to remove both these print statements. So now I'm going to return both these host name and host IP back to the caller who is calling this particular function. So if you want to add some comments, you can add them like this. So hash is for the commenting, function to fetch host name and IP of the host name and IP. So wherever this program runs, it is going to fetch those details. So I'm going to return host name and host IP. So I wanted to return them as a string, so I'm going to use this data conversion. So I'm going to convert them into different data type called string. So now I have this host name and host IP, so I can dynamically show them whenever a user hits this / details. So what I'll do is I'll go to the index.html file, and I'll going to create one more tag, his2 tag. Here I'll create one more particular tag. So this time what I'll write is response from host. So we have to create placeholders. So I'm going to give it a name, host name. So whenever I have this variable host name passed to this index.html, so this particular variable is going to get replaced. So response from host with IP address, and then I'm just typing it as IP. So it should be double braces and spaces should be there. So this is about writing the templating in Jinja. So the dynamic response will be response from host, this particular host name with IP address, this particular IP. So I have to pass the values to this host name and IP. So how will I pass is, so I'm going to pass it in the render template. So I have to pass the host name is equal to something which is question mark, and IP is equal to something which is a question mark. So those IP and the host name and IP information are available here. So I'm going to call this fetch details function just before the rendering. Fetch details, since it is going to return me two values, host name and IP, so I'm going to catch them here. So this is called tuple unpacking. So host name comma IP is equal to fetch details. So this host name has to be sent to the index.html. So this is the actual value. So host name is equal to host name. So don't get confused over here. This host name is this host name, or else what I'll do is I'll write host name in caps over here, okay, and IP in caps over here, and then so this becomes your host name, which is capital, and I'm assigning a value which is this, and also for IP I'm assigning a value small IP. So this is how you render the dynamic a template. So I'm going to start the server once again. So now I'll go to the slash details and I'm going to refresh it. So if you see here, it is saying response from host. So this is the host name with the IP address of this. Since I'm running only one instance, so you're going to get the same instance. Suppose in case of Kubernetes, you're running two different replicas using the deployment object. So you're going to get various dynamic responses from this API endpoint. So now we are almost done with creating the endpoint. So we have the route which is hello world, and then we have the health route, and we have the details route. So now our application is also running properly. So now the first thing the next thing that we are going to do is, so we are going to use pip to freeze the dependencies, because we would like to know what all the dependencies we have used so far inside this virtual environment to create this application. So using pip freeze, I can freeze the dependencies or get all the dependencies from this particular virtual environment, and I'm going to redirect it to requirements.txt file. So this is the file actually pip needs to install all the dependencies from a file. So if I just redirect these dependencies to a different file, and if you open it, so basically these are all the dependencies so that we have used for this application development. So currently it is under the SRC. So what I'll do is I'll bring it outside the main folder. So this is the requirement.txt. Let's say if someone wants to run your application, what they have to do is they have to use pip install -r, and then if you give the file name which is requirements.txt file, so it is going to download all the dependencies which are mentioned in that particular file. So if you are not sure, you can always go to the virtual environment official documentation and see how they are freezing the requirements, and then you can use pip install -r requirements.txt to install all the dependencies. So far we had seen how to run or how to create a simple web application and run it locally. So now what we'll do is we'll try to create a Docker file and see how to Dockerize it. So for this I need to have a cluster which should be your Minikube cluster. So I'm going to go one step back to the main directory, and now since Minikube is already installed and I have kubectl and Helm installed, so I'm going to use Minikube start to start the Minikube cluster. So my Minikube cluster is up and running, and my kubectl is also configured to use the Minikube cluster. So now if I just do Docker, so I'm going to get some output. Okay, so now what I'll do is I'll just see what are all the running containers. So by running the docker ps command, so if you see I'm not able to connect to the Docker daemon, which is basically running inside the Minikube. So the way I can do is I can just get all the environment variables of Docker inside Minikube by running Minikube docker env. So I can set all these environment variables. I'll copy all the first four, and then I will use them. I'll set all the environment variables. So now if I do docker ps, I'm going to get the various containers which are currently running inside the minikube cluster. So now what we'll do is we'll start to write a simple docker file. We are going to close everything. So inside the readme, so we are at this step, writing a simple docker file. So on the main directory, I'm going to create a new file called Dockerfile. And also when you're trying to build it, I don't want this tutorial env to go to the daemon during the Docker build stage. So I want to exclude it from going from the Docker context. So what I'll do is I'll create a new file known as docker ignore. So this will ignore any files that I input in this file during the Docker build stage. So I'm going to input the same tutorial -env. So this won't be sent as the Docker build context. So tutorial env. So now let us go to the Docker file. So first and foremost thing that we will do is selecting the base image. So I'll go to the Docker hub and see if base image Python is available. So it is there, but I wanted to select a proper tag. So I'm going to search for Python, click on this and see various tags. So I can use the latest one. This is 338 MB, but this is not needed for me. So what I'll do is I'll select a smaller one called the Alpine version, and Alpine I'll take something with 3.10 as the tag. Yeah, so you can take 3.10 -alpine. So it is just 16 MB. So I'm going to take this as the base image because I don't need everything that comes in the latest version of Python. So I'm going to take this as the base image of the Docker. So base image for this application. And now what I have to do is I have to build this image. So first thing that I have to do is I have to copy this requirements.txt so that pip will install all the dependencies. So I can use copy statement, copy requirements.txt into the directory. So inside the image it is dot, but before that, so I wanted to set some working directory. So I use workdir as /app. So it is going to copy this requirements.txt into this particular app directory. So now what I have to do, I have to use run pip install -r and then requirements.txt. So that will read all the dependencies. So if you open this requirements.txt, these are all the dependencies that we are needed. So I'm going to install all the dependencies, and then I'm going to copy the source code, which is src in our case, and then I'm going to copy into the src directory. So it will be copying into /app/src because we have set the working directory as /app. So once this is done, so I have to have the entry point created. So as an entry point, what I have to do, I have to run my Python application. So I'm going to use the executable form. So Python followed by the name of the file which I wanted to run. So I wanted to run inside the src, that is /src/. So we have app.py file. So this is the file that I'm going to run, and I'm also going to use expose just for documentation. So my particular container is running on port 5000, and I will also want to include the health checks, because if you see the original source code, I have created a health endpoint called /health. So I'm going to add this in the health check. So if you just type health check, it is going to give you all the various flags, like the interval 30 seconds, timeout 30 seconds, start period 5 seconds, retries 3. So interval 30 seconds means every 30 seconds this health check command is going to run, and timeout is it is going to wait for 30 seconds. So within 30 seconds, if it is not going to get a response from the application, so it is going to mark it as failed. Start probe is 5 seconds. So this is the initial delay that we want to wait. So before health check commands are run, so I am changing it to 30 seconds. and retries as 3. I'm going to increase it as 5. So after 5 failed requests, this health check gets failed, and the container is marked as unhealthy. So for the command, what I'll do is I'll simply use curl and then -f, which is a fail flag, and then on the local host, okay, I'm going to break it into 2 lines by giving slash at the end, and then command curl -f http localhost, and on the container is running on port 5000, and the health endpoint is /health, and or exit 1. So this is going to give me the exit 1 as the response for the health check if the curl to this particular endpoint fails. So this is how you write the Docker file. So now what I'm going to do is I'm going to build this Docker file. So I'll use docker build -t. So I'm going to just name it as web app :1.0 and dot to indicate the location of Docker file. So this is going to download the base image, and then it is going to install all the dependencies and then build the final image. So now everything is done. So image is successfully tagged. So in order to run it, what we'll do is we'll use docker run command. So it is docker run -d. So port mapping, I'm going to map 80 on the host machine, and the container port as 5000, and the container I wanted to name it as a web, and the image name is web app :1.0 as the tag. So this is started. So if you just do docker ps, so you are going to see this OS container, web container. So now I'll go to the browser and see the output. So but before that, I need to get the IP address of minikube by running minikube IP. But if you're running the cluster, you can also take the master's IP address. In my case, master's IP address is this. So I'm going to take this IP address, and since my application is already running on 80 because I used port mapping, so I can simply run this IP address. So this is the /output /endpoint output. If you see the /health, this is going to respond with the health endpoint. So application is up and running, and I can also do the details. So this time it is going to give me a different value. So this is the host name or the container ID, and this is the internal IP address of the container. So if you keep refreshing, you are going to get the same value because there is only one container for your application. And also if you do docker ps and the web, docker ps, so you can see that the container health is starting. So that means health has not updated yet. So if you check after 1 or 2 minutes, so this container is going to be marked as healthy. So this is it. So I'm going to remove this running container using docker rm-f and the name of the container as web. So now what we are going to do is we are going to see how to write a Docker Compose file for deploying this application using Docker Compose. So I'm going to create one more file, so and name it as docker-compose.yml. so this is the standard name. So what I'll do is I'll start with the basic template. So you can go to the web and then search for Docker Compose. So click on the first link. So this is Docker Compose. I'm going to take this particular template, and I'm going to copy the entire template over here. So the version of the Docker Compose is currently 3.9, and this is the service. So we are making one service. So I'm going to delete this volumes and links because there are no volumes and links, the other image and the volume. So I'm just starting with the bare minimum one. So this is the web, which is the container, the service name. So what we'll do is, so we are going to take this and extend this. So it is up to you to build the image inside the Docker Compose as well, or directly refer the image. So let's see how to build it. So inside the build, you are just giving dot, that means finding the Docker file in the current working directory. At the same time, you can also use context. So this is also the same thing, context colon the dot, that means finding the Docker file in the current directory. So if the Docker file is named properly with the same name called Dockerfile with capital D, we don't have to give the name. So if it is the Docker file is named with a different file like the my Docker file or Dockerfile -dev, so in that case you have to mention the Docker file name as well, or else even if the name is Dockerfile, you can also use this particular statement. And then I wanted to change the image name. So once this is built, I wanted to name it as web app. So earlier it was 1.0, now I'm going to use web 2.0. And coming to the port information, the container port is 5000, but on the host machine I wanted to use it as 80. And I will also put the restart statement. So the restart I always wanted to use always, so even if the container fails, it will automatically restart. So it is up to you to use networks. That means that putting this particular container in a particular network like webnet. That means that if you wanted to put it in a custom network, so you have to create it first. So I'll use a network section over here, and then use webnet. So do sure you indent it properly. So you created the network called webnet and you are referring it here. So this is the complete Docker compose file. So we have the images, port, restart, networks. Yeah. So now first thing what we do is we try to build this particular image using this build instructions inside the Docker compose. So what you can do is you can just use Docker compose and an option known as build. So this is going to build your Docker image if you have the Docker file in the current working directory. So this is just building it, and it is going to tag it with web app 2.0. See, it is tagged. Now we can also use Docker compose up -t. So this is going to bring up your complete stack. So the network is created and then the container is started. So if you just do Docker ps, so you should be seeing that particular container up and running. So it is the same process again. So we will go to the, we'll take the IP address of the Minikube. So I'm going to take it one more time, Minikube IP. So take this IP, enter, and slash. So this is the slash endpoint. So we have the slash health, which is the health information, and we have the details. So this is also same thing. So this is how you deploy a web application using Docker compose. So now I'm going to bring down the complete stack by running Docker compose down. So this will bring the complete Docker compose by removing the container first. So it is currently stopping the container, and then network is also removed. So this is about Docker compose. So now Docker compose is done. So let us now move to writing the Kubernetes deployment and the service object files. So what I'll do is I'll just close everything. So for Kubernetes also, I'm just going to create a separate folder inside this. So I'm just going to name it as Kubernetes. So inside it I am going to create two files. So first file is deployment.yaml, and the other file would be service.yaml. So the service, yeah, so the deployment. So first one we have to go is a deployment. So you can use the web reference for taking the template for the deployment, but in my case I already, so API version is, it is app/v1. So we can also refer the official Kubernetes documentation. Like we can just go for kubernetes.io, or you can just type Kubernetes deployment, then take the template from here. So I'm going to copy the same thing. So the API version is apps v1, kind is deployment, metadata is nginx deployment. So I'm just going to take it as I'll name it as Python web app. So labels I'm just using as web. Replicas I'm going to put it as 2. Select as app is equal to web. So let's come to the template section first. Inside the template metadata we have the labels. So I'm going to create a label known as app is equal to web. And for the containers we have the web app as the container, and the container image name is so web app 1.0 or 2.0 anything, and the container port is basically 5000. And since this is the label for this particular containers, so we have to use the selector also the same thing, app web. So this is about the deployment file. So now let's go to the service object. So I'm going to do the same thing here, and I'm going to search for service, and I'm going to take this particular, so we'll take the node port because we need to expose it outside the Kubernetes cluster. Yeah, so this is the node port. So I'm going to take this file and then paste it. So app v1 kind is service, metadata is, so I can just name it as web service, type is node port, selector app as web because that is the selector that we have used for the containers. Port is 80, but the target port is 5000 because the container ports are 5000. Node port if you remove, so automatically the node port is selected. So this is the just the bare minimum one. Okay, so this is what our service object looks like. So now what I'll do is, so I'm going to deploy both deployment service. So I'll switch to the Kubernetes folder, and then I use kubectl apply -f deployment.yaml. So deployment is created. If you just do kubectl get pod, so you can see that both the pods are in the running state. And now let us deploy the service object, kubectl apply -f service. So the service is of type node port. Service is also created, kubectl get pod comma service. So this is the node port of the service, which is 30827. So I'm going to use this port number. So the IP address colon 30827 enter. So this is the output, and then if you just fetch for the details, so you can see that this is the response of the details endpoint. Now if you keep refreshing, you're going to get the different information because now there are two pods answering your query. So these pods are load balancing the request through the service object. So for every click you're going to get a different response. So these are the different Kubernetes manifest files. So now what I'll do is I'm going to delete both these objects by using kubectl delete -f dot. So whatever the files existing in this directory, so all will be uninstalled. So now even Kubernetes manifest files are done. So our last step inside the readme.md file is to create a Helm chart. So how do we create a Helm chart? So first of all, you have to have the Helm CLI. So if you have the Helm CLI, so what we can do is, so we can create a template first. So the template is Helm create. I'm going to name this template as web app. So this is going to create a template. Now if you open the template, so there is a charts directory, templates directory, Helm ignore, chart.yaml file, values.yaml file. So I don't need this chart directory because there is only one chart. So there are no dependencies. I'm going to delete this. And also inside the templates, there is a test directory which I don't need. I'm going to delete it. And HP I don't need it. I'll delete. Ingress also I don't need. I'll delete it. Service I need. Service account I don't need it. So inside the templates I only have 4 files. One is the helpers file which I need, deployment.yaml file which I'm going to edit, service file, this is for the exposing the service, and nodes.txt. So these are the various files which I generally need. So first of all, before modifying any of the objects, so let's see what are the values present in chart.yaml file. So chart.yaml file will have all the metadata like the API version of the Helm, which is v2, that means we are using the Helm 3. So the name of the chart is web app, and various other parameters like type, version of the application, app version, etc. So if you go to the values.yaml file, so the default replica count is 1. I'm going to change it to 2. So repository information, so repository is web app, and the tag information is 1.0 or 2.0 if it is your wish, and pull policy if not present. And we don't need service account, pod annotations and all. If you want, you can just write them. And service type, it is not cluster IP, it is node port. We are going to expose it. So there is no target port here, we are going to create them. Ingress is by default it is false, because we are not using an ingress controller. So auto scaling is also false. So everything is perfect in values.yaml file. So let us now go to the deployments.yaml file and see what all changes we can do. So the kind is deployment, metadata is having some name and labels, that is fine. So what they are saying is, if auto scaling is enabled, then only reuse replicas will take effect. So I don't want this, so what I'll do is I'll just remove this auto scaling enable. So replicas is taking values from values file, replica count. So if I see the values file, this is the replica count. And now the selector, yeah, it is taking from the helpers file. Template, metadata, annotations, it is fine, but I don't need any annotations, so I'm just going to remove them. Or else even if you put the annotations, it is completely fine. So it is up to you. So I'm just removing them. Spec image pool secret, so there are no image pool secret, so if you want you can keep it. I'm just removing it. So service account we don't have, I'm removing it. Security context also we don't have, we are removing it. So container name, security context also we don't have, we are removing it. So image is taking from the values.yaml file. Pull policy is also the same. Port, this a container port is marked as 80, but it is 5000. So what I'll do is I'll create one more value inside the service here. So what I'll do is I'll create a different value known as target port, and I'm going to put it as 5000. So what I'll do is I'll take this target port value and I'm going to put it here. So the way I'll put it is, so dot values dot service dot target port. So this is the port that I wanted to replace here. And readiness and liveliness, probe and resources, I don't have anything, so I'm going to remove everything from this point. So to make it very simple, so this is the final template for the deployments file. So I'm going to save it. So the same thing I'm going to do for the service. So for service, name labels are fine. Spec, it is the node port which we just changed. And then service type, yes. Port, target port is HTTP. No, target port is not HTTP, it is 5000, which is the container port. So basically we just did it in values.service.target port, and the port is 80. So this is also fine. So now before applying this Helm chart, so I'm going to render it. So how will I render it? So using Helm template and the name of the chart, which is web app. So I'm going to render it. So this is how your complete manifest file looks like. So there is a service object which is of node port type, container port is 5000, service port is 80. And coming to the deployment, there are two replicas. So these are the selectors and these are the labels for each container. And then web app 1.0 is the container image, and these are the various ports. So what I'll do is we'll release this Helm chart by using Helm install, name of the release as, let's say, web app, and then the chart which is again a web app. So it is up to you to name the release as web app or simply web, and then the folder where you have the Helm chart. So this is going to release your chart. So if you do Helm list, so you're going to get this particular release, which is the name web release 1 and the status as deployed. If you just do kubectl get pod svc, so there are two containers, two pods which are running state, and the node port is as 30211, sorry, 30221. So I'm going to change this port here, 30221, and then slash. So it is going to respond with the same thing, and then check the health, which is /health, and also check the details. So this time also there are two parts as answering your request. So if you keep refreshing this page, you are going to get the different information because there are two parts answering your query. So now even the Helm chart is also done. So what we'll do is we'll uninstall this release using Helm uninstall and the name of the release, which is a web release. So now even this is also uninstalled. So we have started with writing this simple Flask based application. We have created 3 routes, /health and details. Then we executed this locally, and then we containerized it by creating the Dockerfile and also creating the Docker compose file. And then we created various Kubernetes Manifest files like the deployment and service object, and we had also seen how to create a Helm chart. Now I'm going to push all this content to the GitHub. So first I'll check the status using git status. So all these files are to be added. So I will just use git add -a and then check the status again, and then I will use git commit message. So git commit -name. I will do commit message as a web app, and then I'll just use git push origin main because this is the default branch. So if you want, you can also create a new branch before making all these changes and push it to that particular branch. Now if you go to the git and then refresh this page, you're going to get all the information. So that's it for this video. If you like our video, kindly subscribe to our YouTube channel and join our Facebook group. The links are given in the description below. Thank you.